Summer temperatures in the American Southwest routinely exceed 105 degrees, sometimes reaching 115 to 120 degrees during extreme heat waves. The Pueblo peoples of this region built multi-story apartment complexes more than 1,000 years ago that maintained comfortable interior conditions throughout these brutal summers, using zero external energy inputs. Archaeological evidence from sites including Mesa Verde, Chaco Canyon, and hundreds of smaller pueblos documents consistent construction approaches that produced reliable cooling in the hottest American climate using purely passive design principles. The techniques relied on thermal mass, appropriate orientation, ventilation patterns, and specific material choices that together delivered thermal performance matching what modern air conditioning provides at enormous ongoing energy costs. The Pueblo construction tradition continued for centuries and influenced subsequent Spanish colonial and territorial American architecture throughout the Southwest. Despite this established regional building tradition, contemporary construction in the American Southwest has largely abandoned these proven passive cooling approaches in favor of mechanical air conditioning. The homes being built in Phoenix, Albuquerque, Tucson, and El Paso today consume enormous quantities of electricity for cooling, while their neighborhoods contain preserved pueblos from 800 years ago that remained comfortable without any cooling equipment whatsoever. The information required to build Pueblo-style passive cooling into contemporary homes exists in extensive archaeological documentation and in the work of regional architects who specialize in adapting these traditional approaches for modern applications. The fundamental design principle underlying Pueblo cooling involves thick thermal mass walls that absorb heat during the day and release it gradually during the cooler night hours. Traditional Pueblo walls typically measure 18 to 36 inches thick, constructed from stone, adobe brick, or rammed earth, depending on regional material availability. This substantial mass creates a thermal time lag effect where peak outdoor temperatures occurring in mid-afternoon don't penetrate the interior space for 10 to 14 hours, meaning peak interior temperatures occur late at night when they can be dissipated through ventilation with cooler nighttime air. The reverse effect operates in winter when walls that absorbed sun energy during the day release it to the interior during cold desert nights. The wall materials common in traditional Pueblo construction included locally available stone for foundation and lower wall sections, sun-dried adobe bricks for upper walls, and mud plaster finishes for weather protection. Adobe bricks, typically measuring 10 by 14 by 4 inches, contained a mixture of clay soil, straw, and water that developed substantial structural strength during sun-drying processes. The combination of stone and adobe produced walls with thermal storage capacity of approximately 35 to 55 pounds per square foot of wall surface, providing substantial flywheel effect for temperature moderation across the daily cycle. Modern alternatives including compressed earth blocks, structural rammed earth, and concrete masonry with appropriate mass can replicate these thermal characteristics using contemporary construction methods. The building orientation and configuration principles applied across traditional pueblos created cooling effects through careful site planning. Pueblos were typically oriented with their primary facades facing south, allowing winter sun to warm interior walls and floors while minimizing summer sun exposure through the appropriate geometry. Roof overhangs and projecting upper stories shaded lower levels from high summer sun while allowing low winter sun penetration. Interior courtyards and plazas created shaded gathering spaces with substantial thermal buffering from surrounding building mass. The spatial arrangement optimized for passive thermal performance across seasonal cycles. Teresa Mondragon operates a specialty architecture practice focused on traditional Southwestern building techniques adapted for contemporary residential applications. She has designed 34 homes across New Mexico, Arizona, and Colorado since 2010, each incorporating substantial Pueblo-inspired design elements. Her typical residential project uses rammed earth or compressed adobe walls ranging from 18 to 28 inches thick, substantial thermal mass floors, of tile over concrete, south-facing primary rooms with appropriate overhangs, and traditional window patterns that minimize heat gain while providing adequate daylight. Her documented client homes show typical cooling energy consumption of 1,800 to 3,200 kilowatt hours annually, compared to 9,000 to 14,000 kilowatt hours for conventional southwestern construction of comparable size. Annual cooling cost savings average $1,100 to $1,800 per home. The ventilation strategies in traditional Pueblo construction captured the substantial daily temperature swing characteristic of desert climates. Summer daytime temperatures reaching 105 to 115 degrees typically drop to 55 to 70 degrees during night hours, creating opportunities for nighttime ventilation to pre-cool building interiors. Traditional Pueblos included small windows positioned for cross-ventilation with openings at low and high elevations, creating stack-effect airflow patterns. Residents opened windows during cool night hours to flush accumulated daytime heat from interior spaces, then closed windows during morning hours to retain the cool conditions through hot afternoons. The cycle repeated daily throughout summer months, maintaining comfortable interior conditions through the combination of thermal mass storage and strategic ventilation management. The roof construction in traditional Pueblos provided both structural function and thermal performance. Typical roof assemblies used vigas or primary timber beams spanning across spaces, supporting layers of smaller latillas or saplings, then a layer of brush or small materials, and finally, substantial earth or adobe topping measuring 8 to 18 inches thick. The earth roof provided substantial thermal mass at ceiling level, absorbing heat during summer days and radiating it upward during nights. The insulation value combined with the mass effect reduced heat gain through roofs substantially compared to contemporary lightweight roofing that offers essentially no thermal mass benefit. Luis Chamberlain leads a construction firm in Albuquerque specializing in traditional southwestern building methods adapted for current building codes and modern lifestyle requirements. His firm has completed 87 residential projects since 2008, with documented performance data showing consistent cooling energy reductions of 65 to 82% compared to baseline conventional southwestern construction in equivalent climate zones. His projects typically use compressed earth block walls, traditional viga roof construction with substantial earth topping, and integrated courtyard designs that provide shaded outdoor living space. Total construction costs typically run 18 to 28% above conventional construction, with payback periods of 5 to 9 years through operating cost savings. The interior finishes in traditional Pueblo construction contributed to thermal performance alongside aesthetic and practical functions. Mud or lime plaster wall finishes provided breathable surfaces that supported moisture management without trapping humidity. Bancos, or built-in masonry seats along walls, added thermal mass at occupant level. Traditional fireplaces called kivas fireplaces provided winter heating while adding significant thermal mass to room spaces. Earth-toned finishes throughout interior spaces reduced visual contrast with thermal mass elements while providing warm colors appropriate for cooler winter periods and cool colors appropriate for summer use. The water integration practices in traditional Pueblo communities supported cooling through evaporative effects. Ceramic water jars called olas placed near windows allowed evaporation to cool incoming air during hot afternoons. Courtyard fountains and water features, where resources permitted, provided evaporative cooling effects across gathering spaces. Even simple water-filled containers in interior spaces contributed measurable cooling through slow evaporation. These water-based cooling strategies required minimal infrastructure while producing meaningful thermal benefits in dry desert climates where evaporation rates remain high. Isabella Otero teaches traditional building techniques at a community college in Arizona, having trained over 600 students in various aspects of Pueblo-inspired construction during her 18-year teaching career. Her programs emphasize both the technical construction details and the underlying thermal principles that make traditional design successful. Her former students operate construction businesses across the southwestern region, continuing the tradition of building homes that work with desert climate conditions rather than against them. The educational pipeline she supports has contributed substantially to the regional capacity for traditional construction, though the total number of homes built using these approaches remains small compared to conventional desert construction. Now for the obstacles and considerations that affect Pueblo-inspired construction in contemporary American contexts. First, the construction costs for thick earthen walls exceed conventional light frame construction. Rammed earth, compressed adobe, or similar traditional wall systems require substantially more material and labor than 2x6 framed walls with insulation. Typical cost premiums run 20 to 35% above conventional construction for comparable home sizes. While operating cost reductions eventually offset the initial premium, the initial investment challenge deters many potential projects. Second, construction timing for earth-based building approaches depends on weather conditions. Adobe and rammed earth construction requires dry weather for proper material behavior, limiting construction to drier periods of the year. Projects in regions with unpredictable weather patterns face scheduling challenges that add cost and time compared to conventional construction that proceeds in most weather conditions. Thoughtful project timing addresses this issue but requires careful planning. Third, qualified contractors with experience in traditional construction methods are concentrated in specific regional markets. New Mexico, Arizona, and portions of Colorado have established communities of builders familiar with these techniques. Homeowners in other southwestern regions or in adjacent climate zones that might benefit from similar approaches face limited contractor options. Finding qualified builders sometimes requires importing specialists from established regions at additional cost. Fourth, building codes in some jurisdictions present challenges for traditional earth-based construction. While New Mexico has developed comprehensive codes supporting these techniques, some adjacent states and specific local jurisdictions lack clear code pathways for approval. Engineering and permitting processes can require additional time and expense compared to conventional construction with well-established code compliance paths. Fifth, the aesthetic and spatial characteristics of traditional Pueblo-inspired construction don't appeal to all homeowners. The thick walls reduce apparent window sizes, the earthen color palettes differ from mainstream architectural styles, and the courtyard-centered floor plans require different spatial organization than conventional open-concept designs. Potential buyers and homeowners must genuinely appreciate traditional Southwestern aesthetics to find these homes appealing as living environments. Despite these considerations, Pueblo-inspired construction remains a proven approach for Southwestern residential applications. The 1,000-year track record of successful examples provides compelling evidence that few alternative approaches can match. The specific microclimatic adaptation features of traditional pueblos demonstrate sophisticated understanding of local conditions. Different Pueblo regions developed specific variations optimized for their particular climate challenges. Higher elevation pueblos in cooler mountainous regions emphasized winter warmth retention through substantial thermal mass and compact clustered configurations. Lower elevation pueblos in hotter desert regions emphasized summer heat rejection through different orientation, ventilation, and shading strategies. The variations within the broader Pueblo tradition reflect centuries of experimentation, and refinement across diverse climate conditions, producing design solutions finely tuned to their specific locations. The social and communal aspects of traditional Pueblo construction supported thermal efficiency through shared infrastructure. Multi-family residential complexes with shared walls reduced total exterior surface exposure per occupant compared to detached single-family dwellings. Clustered building arrangements created microclimatic benefits, including wind protection, shared shading, and enhanced thermal exchange among adjacent structures. These social construction patterns produced thermal benefits beyond what individual building optimization alone could achieve. Contemporary Pueblo-inspired projects often incorporate similar communal design principles, though adapted for current family structures and lifestyle preferences. The specific adobe brick production techniques refined across Pueblo traditions produce materials with exceptional durability and thermal characteristics. Traditional adobe manufacture involves careful soil selection with appropriate clay content, straw reinforcement ratios developed through experimentation, mixing procedures that produce consistent material properties, molding techniques that create uniform brick dimensions, and curing practices that optimize final material strength. The resulting bricks provide compressive strength adequate for multi-story construction while maintaining moisture resistance when properly protected by overhanging roofs and maintained finishes. Contemporary adobe production, using traditional techniques, produces materials with performance characteristics documented across thousand-year existing examples. The timber selection for traditional Pueblo construction emphasized specific species and preparation techniques appropriate for different structural applications. Ponderosa pine served as primary structural material for vigas and major beams, selected for its strength, durability, and availability in regional forests. Aspen and pinyon served for smaller members, including latillas and decorative elements. The timbers were typically harvested during specific seasons when wood conditions were optimal, then cured for extended periods before installation. These material selection practices, refined across centuries, produced structural wood components lasting for hundreds of years with minimal deterioration. James Red Cloud, a Native American architect with ancestry tracing to Pueblo peoples, practices in Santa Fe and has designed 42 residential projects incorporating traditional principles while meeting contemporary building codes and lifestyle requirements. His documented projects consistently achieve exceptional cooling performance, with typical summer cooling costs of $40 to $80 monthly during peak summer heat in homes where neighboring conventional construction would run $200 to $400 monthly. The thermal comfort characteristics of his homes often exceed what conventional air conditioning delivers, with stable interior conditions that occupants describe as superior to mechanically conditioned spaces. The educational resources available for learning traditional Pueblo construction have expanded substantially. The Old Pueblo School of Traditional Arts offers intensive workshops on adobe construction, rammed earth techniques, and traditional roofing methods. Several regional universities, including New Mexico State University and University of Arizona, offer coursework on traditional regional architecture. Museum programs, including those at the Museum of New Mexico, and various tribal cultural centers provide public education about traditional building approaches. The Earth USA conferences bring together practitioners from across North America to share techniques and research findings. These educational resources support growing American capacity for traditional construction methods. The water harvesting integration with traditional construction addresses the fundamental desert challenge of limited water availability. Traditional pueblos often included cistern systems capturing rainfall from roof surfaces for storage and household use. Flat roof configurations with appropriate drainage channels directed water to storage locations. The captured water served household needs, while the storage systems added thermal mass, contributing to interior climate moderation. Contemporary adaptations incorporate similar water harvesting principles using modern materials and systems, producing homes that achieve substantial water independence along with thermal independence. The environmental implications of Pueblo-inspired construction extend beyond direct energy savings. The construction materials typically come from local or on-site sources, dramatically reducing transportation impacts compared to manufactured materials shipped long distances. The primary materials, including earth, stone, and timber, generate minimal manufacturing emissions. The durable construction produces homes lasting 200 to 500 years, with minimal maintenance, avoiding the replacement cycles that conventional construction requires. The combined impact across the full life cycle produces dramatically lower environmental footprints than conventional southwestern construction. The historical evidence of Pueblo thermal performance continues being documented through ongoing research at preserved archaeological sites. Researchers at Mesa Verde National Park have conducted extensive thermal monitoring of original Pueblo structures across multiple annual cycles, documenting interior temperature stability that remains impressive even after 800 years of service. Similar research at Chaco Canyon, Bandelier National Monument, and various smaller sites across the Southwest continues generating performance data, confirming the effectiveness of traditional design principles. The research also identifies specific features that contributed most to thermal success, providing guidance for contemporary projects that can prioritize the most effective elements within constrained budgets. The cultural significance of Pueblo construction approaches extends beyond pure functional benefits. Homes incorporating traditional regional building approaches support the continuity of indigenous knowledge and craftsmanship that might otherwise disappear as conventional construction dominates. Families building in these traditions connect their homes to 1,000 years of successful regional practice, producing living environments with meaningful cultural resonance beyond purely physical comfort characteristics. The integration with contemporary lifestyle requirements has evolved through decades of experimental projects. Modern plumbing, electrical systems, internet connectivity, and contemporary kitchen and bathroom fixtures integrate smoothly with traditional wall and roof construction. The homes provide all the contemporary conveniences that families expect while delivering thermal performance that conventional construction cannot match. The apparent conflict between traditional construction and modern living has largely resolved through decades of practical experience with adapted approaches. The integration with landscaping and outdoor spaces supports overall thermal performance through strategic planting and shading. Native desert plants surrounding Pueblo-inspired homes provide wind protection, dust filtering, and minor cooling through transpiration. Shade structures, including ramadas traditional to southwestern outdoor architecture, extend usable outdoor space while providing thermal buffering to adjacent building surfaces. Courtyard gardens with appropriate vegetation create cooler microenvironments adjacent to primary living spaces. The integrated approach to site design multiplies the thermal benefits beyond what building construction alone achieves. The maintenance requirements for traditional earth-based construction involve different patterns than conventional construction. Exterior mud plaster finishes require periodic reapplication, typically every 5 to 10 years, depending on weather exposure. Roof drainage systems require regular maintenance to prevent water damage to the earth-topped roofs. Window and door assemblies require attention to ensure proper weather protection. These maintenance activities, while different from conventional construction requirements, remain manageable for most homeowners and typically cost less than conventional exterior maintenance across extended ownership periods. The financial incentive programs available for traditional construction have expanded in recent years. The New Mexico state government has historically supported adobe construction through favorable regulatory treatment. Various federal programs supporting sustainable housing and historic preservation sometimes provide financial support for projects using traditional techniques. Utility programs in some southwestern jurisdictions offer efficiency-based rebates that apply to Pueblo-style construction based on its superior energy performance. These combined incentive opportunities can reduce the net cost premium for traditional construction substantially, improving project economics for interested homeowners. The resilience characteristics of Pueblo-inspired construction during extreme weather events provide meaningful value beyond routine operation. The substantial thermal mass maintains comfortable interior conditions during extended summer heat waves that would push conventional air conditioning to capacity. The earthen construction resists fire, wind, and other threats more effectively than lightweight conventional construction. The structural durability means that extreme weather events rarely produce the catastrophic damage that conventional construction often experiences. Insurance premiums for traditional construction sometimes reflect these resilience benefits, producing additional economic advantages beyond operating cost reductions. Consider what building a Pueblo-inspired home in the southwestern climate means for a family's long-term relationship with their physical environment. The initial construction investment produces a home that works with the desert climate rather than fighting against it. The annual cooling costs remain remarkably low, regardless of outdoor temperatures or electricity prices. The interior comfort characteristics provide thermal experiences that conventional construction cannot deliver. The architectural aesthetics connect the home to regional traditions extending back a millennium. The environmental impact of daily operation remains dramatically below conventional alternatives. The structural durability promises multi-generational service across centuries of occupation. The opportunity remains available to any family willing to build in the traditional regional style, accepting the initial cost, premium, and aesthetic characteristics in exchange for superior long-term performance. The Pueblo peoples solved the challenge of comfortable desert living 1,000 years ago. Their solutions work as well today as they did when the original Pueblos were being constructed. The knowledge persists in preserved examples, academic research, and the work of contemporary architects and builders who have chosen to study and apply these proven approaches. Whether any particular family pursues this path depends on individual values, priorities, and willingness to build differently from mainstream contemporary practice. The alternative exists. The evidence supports the performance. The traditions endure. The opportunity waits for families interested in proven solutions to the universal southwestern challenge of staying comfortable through extreme summer heat.